Hi guys, so in the previous video we have learnt about Bayesian statistics and I told you how you should not remember the formula but you should instead derive it, and I have taught you exactly how to do so. In today's video I will show you practically how to apply Bayesian statistics so that you can predict the win percentage of CSK versus Mumbai Indians at Wankhede. This is going to be an exciting video, so I suggest you watch till the end so that the concept of Bayesian statistics and how to apply it is absolutely fit in your mind. Now, before going to the data, let's understand how do we frame the formula using not using our memory to recall the formula, but using our understanding of it. So basically, what I want is win probability of CSK winning against Mumbai Indians given the match is happening at Wankhede. You have to think of Bayesian statistics as something that updates the prior probabilities. What is the prior probability that CSK probability of CSK winning against me? Like we can perform a weighted average so that we give more weightage to the latest data than to the previous data because the team changes as years and years pass by. So it is sensible to assign more weight to the latest data and not the prior data. So that's why I'll take a weighted average of CSK winning against me and CSK winning in last, let's say, 10 matches. So if CSK is doing pretty well in last 10 matches irrespective of the team, then the probability increases of CSK winning against Mumbai Indians, right? So I will assign weights to it. This can be given as 6 and this can be given as 4. So I'm performing a weighted average so that I get a consolidated performance of probability of CSK winning against Mumbai Indians before any of the condition is applied. The condition of Wankhede is still not applied. Now let us apply the condition of Wankhede. For that we will need the probability of the match happening at Wankhede given CSK has won. Probability of match happening at Wankhede given that CSK won, let's say in last 5 years. Now I'm taking these years so that I limit myself to the latest data and not the data before it, because the team of Chennai Super Kings and Mumbai Indians in earlier years were much different than it is now. That's why I'm considering the five years. Now you will question me, why did I take 5 years and not like last 1 year or 2 years? Because the amount of data will reduce, because in each year CSK and Mumbai Indians have only 2 matches approximately. That's why I've taken it 5 years. So probability of match happening at Wankhede given that CSK has won in last 5 years multiplied by the winning percentage of CSK in general. Like this is the prior probability and this is the condition that I've applied. Now I have to simply divide it by match probability of match happening at Wankhede of CSK versus me, MI of CSK versus MI. Now why am I dividing it? Like I've explained in the previous video, since it is given that match is happening at Wankhede, so I'm dividing it so to neglect the probability of match happening at Wankhede, so that I am kind of normalizing things. If I don't do it, then this probability assumes the probability of match happening at Wankhede also. Now since we have the formula, we can proceed ahead. Now this is team 1 and this is team 2. But what happens sometimes is, for example, Chennai Super Kings versus Mumbai Indians. For example, we have Chennai Super Kings here and Mumbai Indians here. But Chennai Super Kings can also be in the team 2 section. So we don't know exactly how this is divided, team 1 and team 2. So what I will do is I will copy this whole table and I will duplicate it again. But here instead I will remove T1 and I will put it at T2 and I will paste T2 at T1. Now why did I do this? Because when I will filter for Chennai Super Kings here, then I will get these Chennai Super Kings versus Mumbai Indians But now I will also, if Chennai Super Kings is present in team 2, in the original data I would have not filtered it out because I have put a filter only here and not here. So that's why I have duplicated the data now. Even this, since I have copied it and I have replaced team 2 to team 1 and team 1 to team 2, even that will be filtered out. Let me show you how. So first we'll have to find CSK winning against MI and CSK winning in general in last 4 matches. Let's see how many times CSK won with MI. I will simply select here Chennai Super Kings. So earlier we had Chennai Super Kings here also, right? And if I put a filter here, this won't be filtered obviously. So that's why I have duplicated the data and I have replaced team 2 to team 1 and team 1 to team 2 so that I get all the teams data in by filtering just team 1 or team 2 itself. Now I'll simply filter Mumbai Indians. So these are all the matches that happened between Chennai Super Kings and Mumbai Indians. Well, I will have to calculate the winner, so I will just select the winner. It is 17. 17 times it has won. Divide by 37. It is 17 divided by 37. So 45.95 percentage of the time CSK won against Mumbai Indians. Now, what is the probability of CSK winning in last 10 matches against whomever it played with? So I will remove the filter here team 2. I do not want that. Since I won the last 10 matches, so I'll put a filter on date, newest to oldest, and I will select only the last 10 matches. And I will hide everything else. Cool. Now, how many times did CSK win in these 10 matches? Looks like they won 5 times, so that is around 50%. And I will quickly unhide everything. So now this is clear. In last 10 matches is exactly 50%. Now the weighted average will simply be this 0.6 into this plus 0.54 plus 0.4 into this. This is the weighted average. Now to improve the accuracy, what we could have done is CSK winning against me, we could have taken this for last, let's say 5 years or 6 years. But nevertheless, this is a pretty good number. So before happening at Wankhede, just CSK, what is the probability of CSK winning against me? Do not consider Wankhede or any other conditions. It is 47.57%, and this does make sense. Now, we will calculate what is the probability that the match happened at Wankhede given CSK won in last 5 years. Whatever comes after given, we have to filter for that. CSK won in last 5 years. Hence, I will select the last 5 years data. And it is given that CSK won. CSK won in the last 5 years. So I will simply pick CSK won in the last 5 years. What is the probability the match happened at Wankhede? Now, first let me total this out. This is 38. So in 38 matches, CSK won. But what percentage happened at Wankhede? I will simply filter for Wankhede. 6 out of 38 times CSK won at Wankhede in the last 5 years. 6 out of 38. 6 out of 38 times. It is 15.79% and this does make sense. Cool. As you can see, this also considers the probability of match happening at Wankhede. It simply means that if the matches at Wankhede happened less, so this will also go down, right? That's why to neglect that effect, what we will do? We will divide it by probability of match happening at Wankhede of CSK and Mumbai Indians. What is the probability of match happening at Wankhede of CSK and Mumbai Indians, let's say in the last 5 years? In the last 5 years. So I've already put a filter on date. Now I simply have to select Mumbai Indians here. Since the data is of only 2 rows, we will have to expand our selection. Instead of writing last 5 years, let's say in the last 10 years. Because if the data is small, because statistics works with data, and if the data is insignificant, then the accuracy will be pretty low. So I will select last 10 years, 5, 6, 7, 8, 9, 10 from 2015. And since CSK didn't play 2 seasons, so I will select 2 more years of data, let's say 14 and 13. Now what is the probability of match happening at Wankhede of CSK and Mumbai Indians? First I will have to select CSK and then Mumbai Indians. Total 26 match happened between them, which is pretty good number. Now I'll select Wankhede, it is 9. 9 out of 26 matches happened at Wankhede. So now let me calculate the final probability, and here comes the moment of truth. Let's see what answer do we get. 47.5%, 15.79 divided by 34.62. This is the number. So seems like a pretty low number, but if you have only calculated probability of CSK winning against me, you would have just said 45, 46% or maybe 50%, which is wrong. If you would have only calculated this, what is the probability that match happened at Wankhede when CSK won? It was 15.79%. Now this also wasn't accurate. What is more accurate is this, because we have normalized probability of match happening at Wankhede itself. If this would be rare, then obviously the probability would increase. This is how you can calculate the probability of Team A winning against Team B at any given condition. I hope this was very clear to you, and you are amazed by the Bayesian statistics. The only thing that you should keep in mind is how did I come up with the formula. If you can understand the formula, then you can add adjustment to it by your liking. Just I have made an adjustment to the weights. I will once again explain you how did I come up with this, how did I come up with these adjustments, so that you understand the formula, and wherever you apply it you can make the adjustments yourself to come up with an accurate answer. So the probability of CSK winning against Mumbai Indians at given the match is happening at Wankhede depends on 3 factors majorly. The first is how CSK performing in general against Mumbai Indians and against teams irrespective of where the match is happening. This is called the prior probability. That's why I have taken weighted average of CSK winning against Mumbai Indians and CSK winning in last 10 matches. This is basically the component that what is the probability in general of CSK winning this match. Well, it came out to be 47.57%, as this number made very much sense to me because they have won only 50% of the matches in last 10 matches. Let's say if this was 100%, then obviously there is a little more chance that they will win in this match as well. Now the second component was out of many matches that CSK won, what percentage happened at Wankhede, because that is what matters here, because the match is at Wankhede. So how many matches was at Wankhede given CSK won. So how probability of the match happening at Wankhede given that CSK won. So if this number is high, it means that they have won more matches in Wankhede. That means they have won more matches at Wankhede than at any other stadium. So this is the probability with respect to the stadium. So here they have won 15.79% of matches in the last 5 years at Wankhede. That means 85% of the matches they have won not at Wankhede but at other stadiums. Now if we multiply them by both, then we will get a very poor number. Let's say I multiply this and this. This gives me, let's say I multiply this with this. This gives me a very poor number, which is 7.51%. But this also considers the probability that match happened at Wankhede. What if the number of matches happening at Wankhede is less? That's why we need to normalize it, and that's why I have calculated the match. What is the probability of match happening at Wankhede of CSK and Mumbai Indians in the last 10 years? So if we then divide this by this to normalize it, we will get, so if we divide this with this, then we will get this answer which we have got earlier. I hope this all makes sense to you. This number is the probability of CSK winning against Mumbai Indians at Wankhede, given that CSK has played all those matches. So let's say CSK has played 50 matches, let's say CSK has played 100 matches, and they have won 7 of them at Wankhede against Mumbai Indians. So this also considers the probability of Wankhede. That's why we need to normalize it, and hence we are dividing it by this number. That's why you can make that's how you can make adjustment by calculating the weighted average, and you can go, and if you think that CSK has a great momentum, then you can change the weights to 0.3 and 0.7 as well to give more weightage to the last 10 matches. But in this case it won't matter much, as I will show you how. But in this case it won't matter much because there isn't much difference between 45.95 and 50. So even if I do that, you see the probability earlier was 21.7, now it has changed to 22.25, which is just negligible. Now with the Bayesian statistics, what happens is that it can update itself. So if let's say this match is happening and you have challenged against Chennai Super Kings because the probability was low, and let's say they loses, so this probability will change, and once this changes everything else will change. Just see how. Let's say CSK loses this match and the probability goes down by 40%. You see all the numbers have changed, now the probability has dropped even more. But let's say somehow they have managed to win, so the probability will increase to, let's say, 50%. You see this has increased, but this will also increase because the match is happening at Wankhede. So let's say this becomes 40%, and even this will change because since CSK has won, this probability will increase to, let's say, 25%. Now see, the probability has increased to 31.25% just because CSK has won. Now let's say CSK loses. What happens if they lose? Let's say this goes down to 40%. Winning in the last 10 matches since they have lost go to 45%. At Wankhede they have lost, so probability goes even more down, 40%. And since this match happened at Wankhede, so the probability will increase a little bit. Let's say it goes to 38%. You see the probability, you see the Bayesian statistics has updated itself, and now the current probability stands at 16.3%. That is how you can update with the new data using Bayesian statistics. You can also automate every process of it. So as you add new data, the statistics and the as you add new data, the Bayesian formula will update itself and give you the new latest number based on the data available. This was it. I hope you clearly understand how to apply Bayesian statistics, and you really were amazed by how did we come up with the probability of CSK winning against Mumbai Indians at Wankhede. Please like and subscribe if you really found this interesting, and if you want me to make more such videos applying statistics to real world data so that you can learn intuitively and practically. Thank you for staying with me till the end. Thanks. Bye.